Welcome to my YouTube channel. In this video, I'm going to discuss the types of sets. Types of sets. There's what we call null sets. There's what we call the same thing as empty set. Empty set. Null set is the same thing as empty set. We have the singleton set. We also have what is called an infinite set. Infinite set. Finite set. We have the universal set. We have the equal set. We also have what is called the equivalent set. What is called the disjoint set. How does this set look like? Let's look at example to explain the types of set. Consider a universal set called U. These are sets of natural number 1 to 20, 4, 5 to 20. Suppose we have A to be a set of 3, 4, 5, and we have B to be the set of 1, 2, 3 to 10. And suppose we have the set C to be 3, 5 to 15. So what is going to be the A complement? It's the same thing as A bar like this. It means that what? All this belongs to the universal set and does not belongs to A. So the complement of A is going to be 1 is among, 2 is here. We don't have 3 in the complement because 3, 4, 5 is already in the set A. Remove 3, 4, 5 from the universal set and write the remaining set 9 up to 20. So this is A complement. A intersection A complement is going to be an empty set called the null set because they don't have anything in common, because A complements are the set A. So this is called the null set. A intersection A complement is always a null set. So the number 2, we have what is called the singleton set. Singleton sets are the sets that have only one element, only single element. Example, we have A equals to 3, 4, 5. Suppose we have A1 to be 4. Suppose we have A1 to be 4, it is very obvious that A1 is inside the set A. We say A1 is a singleton set. Again, suppose we have A2 to be 5. It is very obvious that A5 is a subset of the set A. Then A2 is called the singleton set. So number 3, we have what is called an infinite set. Infinite set. Example of infinite set is set of integers, natural numbers. Because natural numbers, these are sets that start from 1, 2, 3. It keep on going, we don't even know the end. We call the set that does not have an end an infinite set. So number 4, there is what we call finite set. A is a finite set because A is from 3, 4, 5. U is also a finite set because U is a set of 1, 2 to 20. So U2 is a finite set. B is also a finite set. C is a finite set. A set that has an end of which we know the end is called a finite set. So the number 5 is called the universal set. U is called universal set because A, B, C are under U. That is, U is a superset of A, U is a superset of B, U is a superset of C. A set is called a universal set if there is other set that are under the consideration of the set. So it's called universal set. We have what is called equal set. Two sets are equal if and only they have the same numbers of elements. Order does not matter. Two sets are equal if they have the same elements. Order does not matter. The power set of A is equals to the power set of B. Then we say A is equals to B if and only if they have the same elements. The equivalent set is not the same thing as equal set. Equivalent set. Example of an equivalent set. Suppose we have A1 to B1, 2, 4. Suppose we have B1 to be RA, let me say T. A1 is equivalent to B1 because they have the same number of cardinality. That is, the cardinality of set A1 is 3. The cardinality of what? The cardinality of B1 is also 3. So two sets are said to be equivalent if they have the same numbers of elements. Same numbers of elements. Then we say A1 is equivalent to B1. So the last is what is called the disjoint set. What are the disjoint set? If you watch my previous video, we see that any set with its complement is always a null set. We call it a disjoint set. That is, any set intersect with its complement is always an empty set. This is called a disjoint set. That is, two sets are disjoint if they don't have elements in common. The complement of a set is a set such that X is coming from the universal set and X does not belong to the set B. B is a what? Is a such that X is coming from U, X is not coming from its complement. So the two sets are what? Are disjoint. So we have different ways of what? Of representing a set. There is also called a set builder and a roster form. A roster, or what you call it, a tabular form of what? Representing a set. Example of this roster is what? 2, 6, 8. It's listed verbally, we call it a lot, a listing element. It's called a listing element. Number 2, we can also what is called the set builder form. We call it a set builder form. Example of a set builder form set is what? A equals to X such that what? X is what? An even number less than 10. So this is called a set builder form. In a case where we describe a complement of sets to be Y, such was that Y belongs to the U and Y does not belong to A. This is called a set builder form because we are describing the nature of complement of a set, but we have not listed it. We are describing the nature of the set. But in a case where we listed it to be 2, 6, 8, this is called the roster form, or we call it a tabular form of representing a set. In a case where they say B all prime number less than 11, then in this case, this is what is called a set builder form. So you now be the one to list what this set is saying. All prime number less than 11. Remember that a prime number is a number that what? It has only two factors, 1 and itself. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 less than 11. So we stop at 7. The prime number is a number that sort of have only two factors, 1 and itself. 1 and itself. 1 and itself. 1 and itself. So 2 is a prime number because it has a factor of 1 and itself. 3 is a prime number, it has a factor of 1 and 3. 5 is a prime number, it has a factor of 1 and 5 itself. 7 is a prime number, it has a factor 1 and itself, 7. So less than 11. 10 is not a prime number. 11 is a prime number, but they said less than 11. So we stop at 7. Thanks for watching. In the next video, I'm going to discuss dot operation on sets.